Hello. So this time we're going to calculate an inverse, and to that extent, we'll consider the following uh, linear fractional function, which is given by f of x equals to 2x plus 1, all divided by 3x plus 2. So let's just state a few things about this function. This is clearly its domain corresponds to all real numbers x such that 3x plus 2 is different from 0, right? Of course, equivalently, that would be that x should be different from 2/3. Um, Using interval notation, this would be the open interval from negative infinity to negative 2/3 union with the open interval from negative 2/3 to positive infinity. Right? Okay, so how do we find the inverse of such a function, if there's even any, right? Well, we'll start like this, right? First thing, I'm going to set another quantity y to this expression associated with the function. What would be the case here? Well, in this case, that would be 2x plus 1 over 3x plus 2, right? After this, second step, I will isolate x, again, if possible, right? And with this, keeping in mind the domain restrictions. Right, as always. So let's start. We would say that y is 2x plus 1 divided by 3x plus 2. And then based on this observation, we can say, well, equivalently, we may write y times 3x plus 2. And this in turn would be 2x plus 1. Well, from here, we can say that this is the same as 3xy plus 2y equal to 2x plus 1. Keeping with the manipulation here, we can write something in the following form. 3xy minus 2x is equal to negative 2y plus 1. And then from here, we can say that this is x times 3y minus 2 equal to negative 2y plus 1. Well, finally, dividing both sides by 3y minus 2, we would get that x is equal to negative 2y plus 1 divided by 3y minus 2. Okay, boom. With this, we have an expression, right? An expression that indicates that we can write x solely in terms of y. So now, what we have done is that we express x as a function of y. So, we're going to name this function. Which would be a function g of y. Right? In other words, for this case, we would have g of y is equal to negative 2y plus 1 over 3y minus 2. Now, here's an observation. We can say immediately, just by looking at this particular function, that g of y has as domain the collection of all those real numbers y for which 3y minus 2 is different from 0. In other words, that would be exactly those numbers that are different from 2/3, which we can write using interval notation as negative infinity to 2/3 union with 2/3 up to infinity, right? Excluding those 2/3. Well, one more thing that is left for us to do, which corresponds to a verification step. And what will be that? So we have to verify two things. That when we make the composition of f with g, that's the identity. Meaning, if you input y, you make the composition with g and then with f, you get back y. And if we compose g with f, that results in x itself. So this time, I'm going to do only one of those, and I leave the other one for you as an exercise. And what would be that? Well, it's something along these lines. You would say, first thing, f of g of y. I perform the substitution. This would be f of negative 2y plus 1 divided by 3y minus 2, which in turn is going to be 2 times negative 2y plus 1 over 3y minus 2 plus 1 all over 3 times negative 2y plus 1 over 3y minus 2, and all of this plus 2. Of course, we can simplify this in the following terms. We have negative 4y plus 2 over 3y minus 2, all of this plus 1, divided by negative 6 y plus 3 over 3y minus 2, all of this plus 2. We keep up with the simplification, and this should be negative 4y plus 2 plus 3y minus 2 over 3y minus 2, all of this over negative 6y plus 3 plus 6y minus 4 over 3y minus 2. And we can continue because now the numerator on the top fraction reduces to negative y. The denominator of that keeps as 3y minus 2, and on the bottom fraction we have negative 1 over 3y minus 2, which of course reduces to negative y times 3y minus 2 over negative 1 times 3y minus 2. Since we're working under this domain, right, we can perform this cancellation, and this reduces to simply y, which is exactly what we expected, right, from the verification step. Now, as I said, I'm going to leave the second part of the verification for you as an exercise, and I hope that you like it. Take care.